I can see there's people from all over the world, really, which is going to be really interesting. All right, 6:05. So we've got so far people from Singapore, beautiful, beautiful cold and sometimes sunny Melbourne, always sunny Brisbane, and New York. Alex, how's the weather in New York at the moment?
The weather over here is very hot and humid.
Humid, not so different from probably Brisbane. Rotterdam, yes. Jahn is joining us from Rotterdam, Netherlands. Quite an international crowd.
All over the world, different time zones.
So we've got a few people joined already. We've got around 30. I think we might as well get started now. I'm assuming a few more people are going to be dropping in as we go. So hello, everyone. It's good to see quite a few people joining. We're just dropping in where we are joining from on the chat. So if you want to contribute, it's going to be good to see exactly where in the world we are all logging in from and tuning in from. So thank you everyone for joining. Today is our 5th Computational AEC gathering, and we're very excited to be talking about virtual reality in this session. So I'm just gonna turn my camera on, and I would invite the presenters to also share their camera initially, just to say hi to everyone. So hello everyone, I'm Anders, and I'm gonna be your host for this evening. So before we get started with the session itself, I just want to make sure is my screen still sharing?
Yeah, I can see your screen pretty good.
Perfect. Can you see the next slide?
Yes.
Now? Perfect. So before we get started, I'd like to thank you, Swinburne University, for sponsoring the event and allowing us to use the software. It's good to have a robust platform to be able to share content with everyone. And very special thanks to Jane Clancy, who has been playing the very important role of moderator of the session and making sure the technology works for everyone. So thank you very much, Jane. Very much appreciated. And a special thank you to our event organizers who have been hosts Amani and Giovanni Borgiolo, as well as myself. So thank you, host, thank you, Gio, for facilitating the session and organizing everything. It takes a lot of effort to organize events. I am Andres. Very nice to meet you, everyone. I'm going to be your session for today. Today's event, we're going to be talking about virtual reality. So we have attendees from all over the world. It's quite interesting to see actually how technology has created the opportunity to share information from everywhere, really. So you can see the map here created by Evan Bright of everyone that's been joining the session and will be joining throughout the night. So it's going to be interesting having so many different time zones. And as I say, we're going to be talking about XR today, which is widely known as extended reality. Now, I found a very interesting image to explain what extended reality is. So for those of you who don't know, extended reality it's a term that got coined to explain multiple new technologies, which are virtual reality, augmented reality, and mixed reality. There has been quite a few terms flying around trying to differentiate between all of these, but they are quite different, as we're going to be seeing on tonight's presentation. And extended reality has simply been the one that has been coined to encompass all of these technologies. So a very quick timeline of VR technology. So back in 1956, was created the Sensorama VR, which was the very first machine capable of immersing people into a virtual world. Followed by 1968, when Ivan Sutherland created the very first head-mounted display. Followed by now, 2020, where we have Microsoft HoloLens 2 alongside a whole multiple range of different headsets that we can use for extended reality technologies. So it's going to be really interesting to see how these technologies progress throughout the timeline. And more specifically today, we're going to be talking about extended reality in the AEC, that is Architecture, Engineering, and Construction industry. So I'd like to welcome and thank our speakers. We have Michael Gardiner from On-Site Studio on the engineering side. Welcome, Michael. We have Gwyllim Jahn from Fologram, which is an augmented reality startup. We have Alex Colomb joining all the way from New York City, which is 4 a.m. where you are at the moment. Thank you, Alex. Really appreciate you joining. And we have Johan Hanegraaff from the Netherlands, from Archeo, presenting virtual reality technology. So thank you all. A virtual round of applause for everyone. And we are Computational AEC sponsoring the event. So we have a Twitter, an email, and a website. You guys can follow and send us an email through if you're interested in speaking, on joining, or simply just sharing content with us. We always welcome. So without anything else to add at the moment, let me just stop sharing my screen. Yeah, perfect. So I would like to start with Gwyllim Jahn's presentation. Gwyll, I'll hand over to you. So Gwyll is joining us from Phillip Island today in Australia.
Hi, everybody. Thanks, Andres. So Andres, feel free to share your screen if you want to of this. I'm going to do something quite experimental for this presentation, which is I'm going to present using a online platform for sharing and discussing design that we've been working on, and I decided to do this about 10 minutes ago. So, you know, computational AEC talk, might as well take some risk. Now, for the audience, two things are going to happen. First of all, Andre's going to be sharing what he sees, but I've just shared a link in chat for all of you, and if you could click on that link in chat, it'll take you to the shared studio space that the presentation will be in. And the main advantage of this is you'll be able to move around, look at all the slides, and there's a couple of 3D models in there that I'll be talking about. So it'll allow you to look at those in high definition rather than just sitting here looking at my screen share. So there's a little bit of housekeeping before I kick off this talk. Right, I can see there's roughly 22 of you in here in this space now. So Art Studio, it's just a way of sharing drawings and models, and it's a collaborative shared environment. So I can see there's loads of little name tags floating around everywhere as you jump into this space with me. Because I'm going to be giving a presentation in Art Studio, what I would like you to do for me is down in the bottom of your screen, you'll see 4 purple buttons. Could you please click on that says follow, and what that will do is it will mean that you will follow views that I will share through my presentation, and you will see exactly what I want to show you. So just turn on follow, and I'm going to share a view of the first slide. And you can see from the screen share with Andreas, that's working for him. Hopefully it's working for everybody who has follow on. And now away we go. We can treat this like a, everybody's playing with the tools. Just for now, if you would just be able to, don't click share view or share sketch, otherwise everybody else is going to be copying you. For now, you'll have to be a passive observer. Just follow along, though at the end of the presentation we'll do a bit of a play around in this space. Okay, so my name's Gwyllim. Thanks very much to Alison, Giovanni and Andreas for organising the talk and inviting us to speak about our work at Fologram. I'm going to talk a little bit about the work we've been doing in this sort of space around holographic construction. So trying to replace drawing sets on construction sites with interactive, in-situ, contextualized holographic fabrication information. So we're going to jump across to the next slide. I think Andreas did a good job of contextualizing XR for everybody, but often it's useful to talk a little bit about how the term AR actually came to be. And since its invention by 2 engineers at Boeing in the early 1990s, AR has always been a technology that has been closely related to the sort of practice of making things. It is taking a user out of their physical environment and placing them in some virtualized space, but instead it was sort of conceived of as assisting with complex manufacturing tasks, enabling the worker to see some small amount of digital information within their physical space that enabled them to do some otherwise challenging task more easily. And I think recently this idea of AR as being about displaying a small amount of digital information to assist with some, you know, some sort of physical human-driven task has gotten lost as more popular sort of populist, let's say, uses of the technology. Things like Pokemon Go have come to consume the mainstream understanding of what this technology is and what it does. But I think what we've been doing at Fologram is trying to establish that actually there's some really fantastic use cases for AR, and by the way, I'll use the AR and MR interchangeably, just for the simplicity of this presentation. But there's really fantastic use cases for AR within the creative disciplines. So, you know, anybody who makes something, who works with their hands, whether they're artists, sculptors, fabricators, craftspeople, bricklayers, tradespeople, it tends to be that there's usually some sort of application for situated holographic information within their workspace that will enable them to do something that would otherwise be difficult more easily. One of the reasons that's the case is because when you work in augmented reality, you're typically using natural user interfaces to engage with digital content, so you're not needing to learn an overwhelmingly sort of complex UI like you might find with something like Revit. Instead, you're just viewing some digital information, and typically that digital information behaves the same way that a physical object would. So if you see a button in AR, you reach out and you press that button in the same way as you would with a physical button. And that makes this technology very accessible for people who aren't necessarily literate. We're also finding that it's hugely advantageous to be able to create shared experiences within AR. So being able to have two people see the same digital information in the same space facilitates all sorts of collaborative work that would otherwise be challenging. And of course, having the precise location of digital content in physical space really assists with fabrication tasks that we're interested in. So at Fologram, we work, at least when we're building things, almost exclusively with a headset produced by Microsoft that Andreas mentioned, so specifically the Microsoft HoloLens, and more recently the Microsoft HoloLens 2. The HoloLens 2 is a self-contained computer with state-of-the-art spatial tracking, so it's able to position or work where it is in space and then position like holograms in the correspondingly correct location, better than just about any other consumer device on the market. So this is another important thing to differentiate. AR on a mobile phone through a screen is fundamentally, the use cases for that are fundamentally different to head-mounted augmented reality applications where you're looking through a see-through display, still able to use your hands to perform some tasks like you normally would, and have very, very accurate positioning of holographic content within your physical environment. Okay, what is Fologram? Fologram is, we're a software company. We build software that runs on mixed reality devices. And I guess what we do differently to other people operating in this space is we're really interested in creating a real-time bi-directional link between mixed reality devices and CAD software. Right now, that's Rhino and Grasshopper. So Fologram allows you to view design models in mixed reality and then use the gestures and sensor data coming from your device as input parametric models. What that enables you to actually do is to use Rhino and Grasshopper to build apps. So rather than needing to use game engines like Unity, you're able to build really simple interactive applications and experiences within the CAD software you already use. And you can do that very, very quickly. Essentially, you take a parametric model, you make it interactive in AR, and away you go. So Fologram's a commercial platform. We're a Microsoft mixed reality partner. We have clients all around the world. Those clients range from research institutions to international architecture practices to design houses, startups, and large players in other industries. But as well as having clients that are using Fologram for various projects, we do a lot of eating our own dog food. So we are very interested in using our own software platform to try to push the limits of what we can design and what we can build through partnerships, typically with either research institutions or with small to medium enterprise. And so there's two projects that I wanted to talk about today that will kind of give you a sense of what's possible within each of those spaces. So the first one is this idea of using holographic shop drawings for complex brickwork. So trying to reduce the time, cost, and risk of otherwise, let's say, very experimental, non-standard pieces of architecture. The way that we, essentially that project by Frank Gehry in that previous slide, it's a, fantastically ambitious building, but it was also not a very cheap building. It's not like that sort of architectural experimentation is open to really anyone. It's only for the elite few. And yet we have a whole lot of capability within the industry, capability and let's say demand for pushing the bounds of what's possible to do within that industry. So Colin Barat, the CEO of All Brick down in Tasmania, he's always looking for ways to extend what his team can do to produce, let's say, better quality work, to take on, higher end, more complex, more ambitious jobs. And he's waiting for essentially a piece of technology to come along and enable that kind of transformation within his industry. And so he'd seen some of the work that we've been doing with students within research institutions, doing dry stacked brick walls, playing around with really, really simple parametric models like this, but that are actually pretty difficult designs to deliver by industry. And he invited us to come and have a crack at building one of these projects within the pretty low risk environment of, his own excuse me. So what Colin was interested in is, when he saw this design, and this was a design done by a student at UTAS. The design is not by any stretch of the imagination what's exciting about this project, but it is, it's 600 bricks. Each one of these bricks is in a unique position relative to each other brick within the course. It's pitching out of plane a little bit, this wall, so you can't easily just use plumb bobs and string lines to construct it. And Colin saw this design and he reckoned it would take about 2 weeks to build. And so we were, together with us, we were pretty interested in seeing how much we could knock off that time if you instead used holographic drawings or shop drawings, let's say, to build it. So what we did is we developed a really, really simple interface that allowed Colin and his team to iterate through each one of the courses of the holographic guide. You can probably faintly see this. I'll zoom in. There's kind of white bricks in here. Excuse me. And then we had a kind of a simple holographic interface off to the side that the guys could reach out and push, just like physical buttons. And wearing the headsets, what they would see is a footprint of each one of the bricks in the wall. They would take a physical brick, they'd place it such that it was within the bounds footprint, and just perform a visual check like you see in this image. So when the brick is within the bounds, it's right, and they can lay the next brick. So that allowed Colin and his team to build the wall in parallel. They had a couple of guys wearing headsets, and it wasn't the most skilled guys in Colin's team by any stretch of the imagination. He had an apprentice, first couple of weeks on the job building this wildly complex brick wall, and they were able to take this job from 2 weeks down to 6.5 hours of playing. So a couple of things to point out here. One is, okay, massive saving in terms of construction time, but also, a high degree of certainty that you can deliver a pretty complex project with a pretty sort of broad team. So you're not relying on the one skilled guy who knows how to do this set out work. Instead, everybody can look at the same digital information. You all understand what the intent is of the project. You can see the finished result as a hologram. You have access to the information that you need to construct it when you need it. And as a result, you get pretty happy bricklayers. So after the success of this first project, we were asked to do another one, this time on a real commercial construction site. Because it was a commercial construction site, it's the Royal Hobart Hospital. They were interested in how precise we could make it. We did a little prototype, got the LiDAR scanner out, did a scan, figured out we could get it to within 10 mil. Then got sent some drawings from the architect showing a bunch of these benches inside of the hospital. We had to develop a bunch of holographic shop drawings, so essentially modeling every single brick in the bench so that the players could know exactly where they go, and this time having custom bricks, so custom cutting templates that would allow the bricklayers to get a nice consistent bond through these kind of curving bench structures. So the brickies already knew that they could construct these, working from holographic shop drawings, they could construct these projects in parallel, which would save them a large amount of construction time. But they were also innovating on the job. So they were using holographic templates to hand cut each one of these custom bricks. And they were figuring out workflows and essentially telling us the shop drawing information that they needed to lay these brick walls. So they had different information to lay the block work compared to the bluestone facing bricks. And they were able to produce this like incredibly intricate, highly sort of finished brickwork, again with a significant reduction in construction time. Now, the reason that we like showing this project is just to give a sense of what is actually possible in terms of precision and scale with off-the-shelf, Hollands 2, Hollands 1 headsets and Fologram right now. So some of these benches are up to 20 meters long. And I'll share a nice view of one of them, 3D model of one, and feel free to drag around and have a look at this thing. And this is set out with one single, well, technically it's 2 QR codes. So you have a datum coming from the surveyor, and then you have another code that ensures that your model is in the correct orientation. So setting out the model, it takes 15 minutes. Once you have that surveyor's information, after that, so long as you're managing the physical environment so that it's optimal for the HoloLens to essentially track features in that environment, you're able to position each one of these bricks within construction site tolerances. So this is the scale which is possible right now off the shelf with the HoloLens 1 and Fologram. Okay, I'm going to pull you into the next project now. I'm going to race along. So that's working closely with industry. It's not really pushing the limits, let's say, of what we can design necessarily, but it is pushing the limits of certainly what Colin and his team are able to very efficiently build. The next project that I want to talk about is kind of coming at this sort of opportunity for using AR within AEC from the opposite spectrum, so from the design side. We'd done a bunch of projects where we were sort of, we were doing bricklaying or we were bending sort of steel frames, and we'd never managed to deliver a project which was really, enclosing space that had a bunch of surface effects. And so we were interested in trying to have a crack at designing a pavilion from steam bent timber strips. We felt like there was this sort of poetic potential there with combining this fairly old arcane technology of steam bending with a complex digital model which would show us how to lay out all of the formwork for each one of these strips in the design. So we found a competition. It's the Tallinn International Architecture Biennial installation competition from last year. We started doing some steam bending prototypes in our studio that you see here. So on the right is a holographic model of a chunk of this pavilion design, and on the left is the physical object following that holographic model. And that seemed to work pretty well. And so we put together this design proposal, a couple of hundred steam bent timber strips forming this incredibly complex knot of a pavilion on the site. And this we sort of got thrown under, well, I guess, when we delivered this proposal, we had no idea whether or not it could actually be built. We were probably leaning on the side of it not being possible. And the only steam bending that we'd ever done was that small prototype that I showed you before. And we'd certainly never done anything of this scale working from holographic constructions before. And even the competition organisers actually were very, very skeptical of this we built, but the jury of the competition decided to throw us under a bus and ask us to build it anyway, which in hindsight we appreciate. So once we figured out we had to build it, we started working on essentially figuring out how to steam bend building scale strips of timber. There's like planks of ash bent over a kind of customizable jig. And what you see on the right here is the spring back of that timber. And this is why nobody builds anything from steam bent timber. It's because it's an incredibly difficult process to control. Essentially, the grain and the knots and the specificity of each board of timber means that they all spring back slightly differently after you bend them. And so you never get a perfectly accurate part unless you, A, have a really strong, clear understanding of the behavior of the material, and B, have made very, very complex, expensive, one-off molds to form the part. And so after several sort of months of prototyping, we had about 6 months to do this project and a €15,000 budget. After 2 months of prototyping, we worked out that to resolve the springback problem, we needed to be able to steam bend 12-meter long strips of timber. And because of the budget and because of the time, we couldn't digitally fabricate any parts. So every single part needed to come from the exact same stock material. We needed to have an extremely simple production chain. And so we rationalized our design such that every single strip in this pavilion could be bent from a straight plank of the exact same dimensional material. This is European ash in the end. And so what you see in this image is the unrolled strip of material, and then it's rolled up three-dimensional form, and a curvature analysis showing us where that strip was going to be bending the most to form that, that 3D shape. And this was sort of one of the first places where we needed AR to deliver this project, because all of our ash was cheap, incredibly cheap and full of knots. And so we would use a hologram of the unrolled board when we were laying up our planks to form this strip, and we were making sure that you would never place weak areas of material where there was a lot of curvature in the part. Then to form these strips, again, we're working with augmented reality, and this is an incredibly dumb, simple process. So there's a huge opportunity here, I think. So we're forming double curved, 12-meter long strip parts, but we're forming just using completely ad hoc formwork. We don't even model this digitally necessarily. All you show is a Rhino model of the strip. You've got a bunch of bits of 4x2 which you can screw into a false floor. You screw them in so that there's a surface of the 4x2 that you can bend the strip over, and then you get 6 or so people to hold this piece of timber while it's steaming in a bag to form them over that mold following that holographic guide. And so that's what it looks like once it's been bent. And there's a few interesting things that happen here. It's, you know, when you're making something by hand and by eye, you're working to a pretty broad tolerance. You're never going to get anything millimeter accurate, and you're lucky if you get it centimeter accurate. And therefore your digital models, there's no point having them more than a centimeter accurate, which is one of the things that we discovered, which I'll talk about in a second. So we have these this composite shell of a structure, essentially, where you have steam bent pieces of timber, which are very flimsy, very, very lightweight, bent into shape. And then we had hand bent stainless steel brackets that stiffen the shell in the other direction. And modeling these brackets digitally is an exceptionally complex challenge. The brackets essentially need to weave through a bunch of strips which are all hand bent and not perfectly precise, and yet they stiffen the structure, and so they need to be as precise as possible. And so we ended up doing a whole lot of modeling, which was all done through physics simulations rather than explicit modeling, where you would define a set of constraints on that bracket and then simulate for those constraints in order to approximate the best possible fitting bracket through the conditions of a set of strips, and ensure that that bracket could actually be fabricated by hand. So again, like the timber strips, we used a single dimension of stock stainless steel material. Nothing was prefabricated. Everything was fabricated by hand. Brackets have been modeled. Again, we have an augmented reality application for hand bending the brackets. And once again, this is all due to budget and time constraints. So what you see here is an interface with a set of buttons and a holographic model of the part to be fabricated. The buttons are all connected to Rhino, so you're able to click on a button, it sends some data to Grasshopper, changes a parameter in your model, the model generates the new geometry of the part, sends it back so you can see it on the headset, and all of this happens in real time. So this is step 1 of a bend and step 2 of a bend over here. So there's about 400 of these parts. You know, an average of maybe 20 or 30 bends per part. And we have a holographic model on site showing exactly where these parts are supposed to go. Structure was engineered brilliantly by format engineers, and it showed that there's going to be some deviation in this shell structure while we build it. And, while you're building it, there's a huge amount of deviation in it because you have very flimsy steel, like lightweight steel brackets, and very long, flimsy pieces of steam bent timber. And so together you have no strength, like there's no strength in the structure at all until it forms a composite shell. And this is where the holographic model just becomes utterly essential. And I don't think this project could anyway have been completed without it, because you need to constantly have a reference to where the correct position of every one of these parts goes, so that you can essentially be constructing from a flexible, textile almost. You're able to always be pulling slowly and carefully each one of these parts of the structure into the correct place. And as you do that, the whole structure pulls itself into the correct form. So this is a sort of a view from the inside of the project, a view from the street. But because we're in our studio, we don't really need to look at the slides anymore. We can jump through and have a look at a few views instead. So the pavilion model. It gives you a sense of how complex the actual digital object is. I mean, this is not a sort of a sculpture that you can make up as you go along, because it's 5 meters or so high. It needs to be, properly engineered. You need to be sure that it doesn't fall down. And so we had to precisely model every single one of the pieces in this structure, even though it was imprecisely fabricated by hand. All right, I think that's slightly over my 20 minutes, so Andreas, I'll leave it there. Any questions? Happy to take them. Thanks.
Thank you, Will. Very good presentation, and just still impressed. Like, I remember the very initial stages of the plugin and initial stages of the technology, and everything, and it's gone so far since then. So congratulations on everything. It's really impressive. I just want to remind everyone that you're more than welcome to drop comments, drop questions on the chat here. And as you comment, I'll make sure that I'll refer them to the speakers so that they get answered. I think I'd like to get started with one question, which I think almost everyone would be asking themselves at the moment. I mean, out of the whole extended reality spectrum of technologies, AR is probably the most new one and the one that has been applied the least within the industry compared to virtual reality. I think I would be interested in knowing, since you started developing, what has been your biggest challenge on getting people to adopt or understand the benefits from the technology so far?
Yeah, that's a good question, and one that we get asked a lot, I think. The biggest challenge with any early adoption of a new technology, even if it has some kind of clear potential, is usually a chicken and egg problem. So we have the problem of needing to convince contractors to build in mixed reality, and also architects to design for mixed reality construction. And this pavilion is only possible because we were the designers and the builders. So we were able to design for the way that we were going to build it. Now, builders and contractors then are going to necessarily invest in this new technology until architects start specifying and planning for it, and architects aren't going to start specifying and planning for it until there's capability in industry. So for us, the challenge is really trying to find early adopters, typically design builders, coming up with clear value propositions for constructing things in mixed reality, assisting them to get started. I mean, that's sort of what it's all about, really. And I think that's why, literally designer builders, so art fabricators and people like that are the first to pick up this tech.
Yeah, and that makes sense because they have I guess an instant view of how their work, their day-to-day work can benefit from this technology, whether someone more of the design aspects probably not as evident at the beginning. I guess, yeah, the pavilion that you guys shared, that you did for the Biennale on Tallinn, is probably the best example of how, if you're kind of across the whole process from design to fabrication and you use this technology, it's extremely, extremely useful, and you can streamline the whole thing, really. I think before wrapping up your presentation, just one more question from Horst in the chat. Horst asks, how do you make sure the models are properly geolocated, both in internal spaces and external spaces?
Yeah, that's a good question. Pretty simply, really, like we need to have a surveyor mark. So somebody's got to scratch some mark on the floor that's been kept like precisely positioned. Once we have that known datum, we use visual markers, so printed QR codes, and essentially you have at least two of them. So you have a positional marker and then an orientation marker, and that's enough to work with over the scale of, say, that brick project. Beyond that scale, if you want to be fabricating in AR, so relying on holographic information to show you to sub 10 millimeter precision exactly where something goes, then you'll need to work with either many more markers or a combination of other technologies like substations and things like that, which we haven't invested much research time into, because there's a lot of opportunities at sort of the scale of, say, something that you might prefabricate in a factory environment before jumping right up to full construction, everything in AR scale.
Yeah, I can imagine it's one of the many technical challenges that doing this actually presents. Thanks for answering that question. Thank you very much for the presentation, Will. And just a reminder for everyone, we will be taking a couple of questions for the speakers after the presentations. And after everyone presents, we will be opening up a roundtable for more general questions for everyone. So if there's a lot of questions being asked here and they don't get answers straight after the presentation, they will at the end of the session. So please drop them in. I can see quite a few people joined halfway through the presentation. So for those of you who just joined, a couple of tips. If you're having issues connecting to the platform or you're dropping in and out, one thing that Jahn recommended me is to use the software within Google Chrome. It seems to be working better in Chrome than in other platforms. So that's one tip. And also for those of you who join, tonight we're having Gwyllim, Jahn, who just presented, Michael Gardiner following up the presentation, followed by Johan Hanegraaff, and finishing up with Alex Coulomb. So please stay tuned and please keep dropping your comments in. So without further ado, I would like to hand over to Michael. So Michael Gardiner is Brisbane studio leader from On-Sign Studio. And I think he'll do a much better job than me at explaining On-Sign Studio, which is Auricom's creative technology agency. So please, everyone, welcome Michael, presenting from Brisbane.
Thanks very much, Andres. Can everybody hear me and see my screen?
Yes, we can.
Okay, excellent. Thanks very much. Okay, look, thanks very much for having me, everyone. As you can see, I'm going to be talking about VR and the search for value, and particularly in the context of using VR for engineering projects being delivered to clients. And you'll hear me talk about value quite a lot through the presentation. I've kind of made it the recurring topic. So just very quickly, just about us, just to establish some context. So I work for Auricom, which is a global engineering consultancy, about 7,000 staff around the world. Now within Oricon there is a digital team, and within that digital team is this small creative technology and visualization team that we call ourselves Unsigned Studio. We deliver a whole bunch of stuff. You can see on the right hand side some of the things that we do. We have been playing in the real-time space. Well, we've been kind of doing visualization for about 15 years now. Real-time visualization since 2012, and VR in particular since we got our first Oculus DK2 dev kit somewhere around 2014. We predominantly use the Unity game engine, but more and more we're starting to explore the Unreal Engine as well. And I am the Brisbane studio lead and also kind of in charge of the real-time strategy, so including things like virtual reality. So what is value? You know, you can see the definition just there. The important thing is that value is not just monetary to our clients, and the kind of statement that I make there underneath is really important. So at the current stage of digital maturity in the engineering industry, when it comes to things like virtual reality, it is critical to find that tangible value to increase client uptake. So what actually does matter to our clients? What is valuable to our clients? Obviously, reducing project cost is still a massive consideration. But aside from that, you know, engineering is an increasingly litigious environment, so reducing the risk profiles of a project is very important. And, you know, engineers want to get the best design outcomes that they can. You know, they love to be able to identify and resolve issues prior to construction, because once you're actually out on site during construction and you come across a design issue, it is not only is it very expensive to fix, but more often than not, it is going to be fixed by the on-site construction contractor rather than the design consultancy, which may or may not get you the most optimal result. A big thing is human-centered design these days, and making sure that we're putting the ultimate end user at the very center of our design. They want to be able to rapidly test and iterate on these design solutions, and then of course there's the whole engagement piece, not only with the general community around a project, but with key stakeholders, so such as things like government ministers. And again, I'm going to come back to this because I want to emphasize it, that until we can demonstrate that tangible value, virtual reality will only ever be seen as a gimmick by our clients. And so what that means for us is that we have to be like absolutely certain that VR is going to be able to offer those benefits before we even discuss it with the client as a possibility. So with that out of the way, what I'm going to do is run through a couple of project case studies, and the way that I'm going to frame these is first of all, we're going to talk about the challenge that was presented to the client, then we'll talk about the opportunity that we found, and then the value in particular that we believe that we could provide through innovative use of virtual reality. So the first example is the Shiploader cabin repositioning. Now I can't mention what this project is by name or who the client was or where it is in the world, just due to confidentiality reasons, but it's you know, we're dealing with these giant machines, these ship loaders, which essentially load coal onto a boat, and then it takes the coal away. So basically for this particular project, the challenge for the client was that they wanted to move the operator cabin, which is this thing that's kind of hangs off the boom, back onto the A-frame. Now the boom itself, it can go up and down like to completely vertical. So you can imagine that it's much preferred to be able to get the operator cabin off of that structure for a whole bunch of reasons, like operational effectiveness and workplace health and safety, and what to do in the event of an emergency, and a whole bunch of reasons. So in the process of trying to figure out how they can get all of those off. So the opportunity for Oricon was, you know, as an engineering consultancy, was to work with the client and make sure that the proposed cabin position that we'd selected works from a whole bunch of different perspectives. So it has to work structurally, you know, it needs to still sit on that A-frame and be structurally sound. It needs to work commercially, and it still needs to be a commercially viable solution for the client. So these are some of the ways that we added value to it through the use of virtual reality. So it's obviously the core problem of where to place this cabin, but then there's also the sight lines down into the storage bins. Because if we go back to this image, you know, that you can see that the operator cabin is almost on top of the thing that actually deposits the coal into the ship. So they can look right down into the big containers in the ships, and they can make sure that it's getting spread evenly, and, you know, getting into the corners and all of that. So they're going to lose some of that visibility by moving it back to the A-frame. So we need to make sure that we can still get as much of that optimal sight lines as we can, accepting the fact that they know that they are going to lose a certain amount of vision. So the next thing is exploring the location of where we can place the CCTV cameras, kind of all around the structure, so that they can make sure that there's no blind spots, and being able to tweak that dynamically was important. Understanding what the visual implications are when the tide is low, whether it's high, if you've got a smaller vessel versus a larger vessel, if that vessel is laden versus unladen. So there's like a whole stack of variables that we wanted to explore as well. Any sunlight and glare considerations in the new position, if if the sun happens to rise up over the ocean in the morning, or if it reflects off a whole bunch of steel work right next to the cabin, whether that's going to cause a distraction. The actual internal layout of the equipment, so where the computers go, where these CCTV monitors go, and how many there are, how that impacts vision and things like that. And then just, making sure that the operator is familiar with how it's all going to look and feel for when they actually get up and running. So this is what we ended up creating. So we basically took a 3D model of the Shiploader from our design team. We pulled it apart and we re-rigged it so that it's all mechanical rigging with full constraints. This is sped up a bit, but it also runs at the correct speed as well. And basically every different type of operation of the Shiploader was recreated inside this model, in addition to things like being able to control the tide, being able to control what ship types and whether they were laden or unladen. So we built this giant model. You can see here, this is kind of the desktop view, but we'll jump into virtual reality in a second so you can see what it's like. But it was important that we made that look as realistic as we possibly could. And so what happened was we basically had an operator from this coal terminal, which is in North Queensland. They came down to the office every week and they would test it with us. And then once they were happy that we'd gotten it to a certain level, we picked up the whole kit, packed it up, we flew up and we set up on site, and throughout the course of 2 days they sent something like 25 operators through, and essentially each operator would have a go. They would learn the controls and become familiar with how VR works, and then they would basically try and find that optimal position, because you can see here, this is our software developer Chris, so he's just testing out the VR, and you can see that it's a fairly standard VR environment. We've hooked up all of the controls to the hand controllers there. So you can do things like control that tide, you can control the Shiploader operations, but then you can also control the location of the cabin. So you can move the cabin up and down, forward and back, or out to the side. So again, we basically put all the operators through. They all had a go. Everyone recorded their feedback. We kind of took an aggregate of all of that data, and we made sure that that data was fed back in through our design process for that final cabin location. And we also worked with them to, again, to determine the final location of those CCTV cameras. It was a bit like virtual inception, where we had virtual CCTV piping into a virtual cabin in virtual reality. So that was that project. The next one I'm going to move on to is the airport terminal wayfinding project that we performed for Brisbane Airport Corporation. So up here in the Brisbane, both the domestic and international terminals. And for this this one in particular, this is the domestic terminal, and the challenge for the client was to try and encourage people arriving at the terminal to use the sky bridge, so that this elevated bridge that I've highlighted in red, because what we were finding, or what the client was finding, was that people would pull up in cars to the drop-off zone, and then the passengers would then just walk straight across the roads where these blue arrows are to get into the terminal. Now, strictly speaking, there's not actually anything wrong with that, because there are crossings, and it's a perfectly viable way of getting there. But in terms of safety, they would prefer people to get up into the sky bridge. So this was underutilized, and they weren't quite sure why. So what happened was they commissioned a wayfinding report that was completed by a company called Bureau North, and then they engaged with us to essentially visualize not only the sky bridge and the surrounding terminal, but to visualize that signage report, and to use VR to take people through and kind of try and evaluate the effectiveness of it before they went out and built a lot of this signage. So there was a few different ways that we thought we could explore how to add value with the client. So, one way was trying to understand those passenger behaviours and the way that people would move through spaces. We do tend to find that in virtual reality, people will move from A to B much the same way that they would in real life in terms of the way that they pick their path. The passenger sight lines, whether the signs are visible or not, whether the signage design and color schemes are effective, the signage placement. So rather than just being a static representation of the design, we built a whole bunch of tools to let you grab the signs and start to move them around directly inside virtual reality. So it meant that they could not only view the design, but if something didn't work, then rather than have to necessarily go back to the design package and update it, they could just quickly test things directly inside virtual reality. And also exploring alternative design solutions. So we built a few other tools like the ability to draw walls, to paint people, to turn things on and off, so that we could kind of introduce a few new ideas that we had strictly not related to the signage that we thought might help with their problem. And here is a video. So it's got a little bit of marketing stuff at the front, and then we jump into VR. But one really cool story out of this was that we had border security come through, because in addition to the Sky Bridge, we also did some work that you can see here on the screen in the international terminal in the customs area. And the head of border security came through, and he believed that there was an issue with the height of these glass balustrades on the right-hand side there. He thought that if a security guard was standing in one corner of the room, it would obscure sight lines to the opposite side of the room, and that would be a potential hazard. So the problem was, though, that those balustrades were literally getting fabricated at the time that they were inside the VR model. So the guy kind of pulled his headset off, ripped his phone out of his pocket and jumped on the phone and basically said, called the fabricators. He's like, guys, stop work right now. We need to adjust the design. Unfortunately, they hadn't gotten too far through it. So that's a good example of value, because just the costs that were saved by not having to redesign the balustrade and reconstruct it, paid for the VR exercise probably 10 times over. So you can see from these images here, you can kind of move around and grab signs and move them around as well. And I will just skip through. Okay, so the next one is a level crossing user experience that we delivered out of our very talented digital team based over in New Zealand. This is a project that took place in Wellington, and they're essentially duplicating a line just outside of Wellington, and this level crossing that you can see, which is the one right in the middle of the 3 pink dots on the left-hand side. There's a bit of concern around this one because it was a very big and busy level crossing, and there's a school nearby and a college nearby as well, so there's a lot of pedestrian usage through this particular crossing. So they really wanted to make sure that it was safe and fit for purpose. And the opportunity for us, yes, we could visualize it in VR and we could put people through it, but we really wanted to see how we could push the envelope. So we decided that we'd try and introduce eye tracking so that we could get kind of more effective data metrics to capture. And then also, we were really interested in testing the solution with the ultimate end users of this particular intersection, which was really the school children that pretty much use this every morning and every afternoon. So the ways that we believe that we could add value, and again, this first point, so yes, we could put people in just in a VR headset and we could just move them through the design and capture kind of the basic metrics, but we wanted to start to explore how we could capture that kind of subconscious responses to the design that you can capture through pupil movement. We wanted to use this as an opportunity to identify potential design issues or if there's kind of non-compliance to New Zealand standards. For this particular project, it was a new way of being able to assess the design and also basically encouraging the design team to use to design in 3D more than they normally would, because they knew it was going to feed into this digital model, and that would create a whole bunch of downstream efficiencies across the design life cycle. And then the last point was really important to us because it really let us, it gave us the opportunity to make sure that the school children they had a voice around this design. So they're the ones that are going to be using this probably more than anybody else. And traditionally, that type of subsection of the community would never have the opportunity to provide input to a design. So that was something that was really important to us. So we worked with this technology from Pupil Labs, which basically plugs straight into the HTC Vive. You can see it tracks a whole bunch of different things in the eye. And if I just play this video, this is kind of shows what it would see through the headset. And these are the things in particular that we were looking to capture. So not only a bunch of things that we would capture just through standard headset type movement, but then also the pupil movement. And this was what the end user testing looked like. So we went and set up at a local school. We put 400 students through the model, which was quite a big day, because you have to basically calibrate the Pupil Labs hardware for every student once they've got it on their head. And for that reason, we got back 51 usable data sets. A lot of them, like the headset might slip down because they have such small heads, or a whole bunch of other reasons. So to be honest, I don't actually know if that's considered to be a good success rate or an absolutely terrible success rate, but there you have it, 51 out of 400. And these are some of the things that we captured in terms of the data, the raw data that we pulled out of this simulation. And as you can see on the left-hand side, it was pretty much just a giant data dump that would go into a CSV file. We would then bring all that information together with 3D models into Rhino using Grasshopper to do some basic visualization and heat maps. And then also we would kind of recreate the experience. As you can see here, we basically took the data and punched it back into Rhino and rendered it out, so we could kind of get an understanding of what that looked like at the time for that particular user. All right, so that's that project. So those are the kind of the three main case studies. But what I'll do is I'll just quickly, just conscious of time, I'll very quickly go through just a few other ways that we've added value, particularly using VR for various projects. We've done it in terms of training. So this is an electrical substation training system that we built over in Cape Town through our Cape Town office over there. This is a health and safety application that we built that was internal for Aurecon. So we have this thing called the My Life Saving Rules, and it's kind of like, I guess, Aurecon's version of the OH&S type rules. There's like, 12 life-saving rules. And so we built this this VR simulation rather than people going through and doing the kind of normal 2D kind of question and answer based training for health and safety as a way to gamify it and increase a bit of excitement around it, I guess. We've used it for site and building inductions. So the ones that you can see on the screen now are the new Brisbane office for Aurecon. It was pretty exciting, but it was a very long construction period. So we actually built the whole office in VR, and we took every single staff member through it in the 6 months leading up to moving in. Not only so they're familiar with the building layout, we basically used this to do the full kind of building induction process, but then also just to make sure that there's like a constant buzz generated through the staff to excite everybody about moving into the new office. And then finally, being able to use it for scenario testing. So things like emergency braking, power loss, training on specific safety incidents. This is where we get to build some pretty fun stuff. We've built virtual car simulations, train simulations, bike simulations where you sit on a physical bike, pedal with a VR headset on, with a virtual canoe where you sit in a real canoe and paddle, all sorts of like crazy and cool stuff. All right, so one more slide, which is just in case anybody's interested, kind of what we consider to be some of the things that we need to focus on in VR in the short term. So this is over the next 6 to 12 months, and some of the trends that we're seeing in the industry. So definitely seeing a shift away from tethered headsets onto mobile. This is both inside Aurecon and with our clients. It's just a lot easier to be able to deliver a project Oculus Quest, and we can start to explore how we can actually include that as a standard deliverable, like the headset itself. We want to start to embed VR into some of our larger projects as a bit of an ongoing design tool set. So everything that I've shown you so far was kind of one-off engagements with our clients, whereas we think there's a lot of value in being able to have constantly updated models that follow the the project design milestones, so that they basically have the latest version of their design on tap at any stage of the project. We want to use VR to visualize kind of existing, already constructed assets rather than just purely things that haven't been constructed yet. So things like being able to conduct virtual site visits and have, like, drones, unmanned drones capturing, footage for inspections and things like that. Make sure that we're fully collaborative, so multiplayer in VR. It's the holy grail that everybody's chasing. I don't particularly think anyone's done it super great yet, but it's definitely getting better. But for us in particular, it's not just about having a bunch of people in VR, but it's about having maybe one person in VR, one person on the computer in the office, one person in an iPad out on site, and all being able to collaborate together through that. And then finally, having just more opportunities to sandbox design inside VR. Again, this is something that a lot of companies are starting to move towards as well, just because there is a tremendous amount of value of just being able to very quickly explore a whole bunch of things, pull models in, apply materials, load and save models and data. So look, that's about it from me. So I'd like to thank everybody for tuning in, and I'm going to throw it back over to Andre and to any questions. So thank you very much.
Thank you, Michael. I think, it's kind of tricky running a virtual event because you can't really see or hear anyone else. But I'm sure everyone will agree that this presentation throws a lot of light into what actually means to do VR in a commercial environment, and what are the value that a client can take away from a technology like this. There is a question coming from Nick Vandenberg. He says, what have you found the biggest roadblock for clients using VR is, and how have you overcome that?
Yeah, okay, look, that's a great question. So there's a few roadblocks that we tend to find. Again, going back to that original kind of statement, there is a general opinion in the industry that VR is just a little bit of a gimmick. It's not until you can't demonstrate that value. The good thing is that the more you do it, the more examples you have and case studies that you can draw on to be able to have those good conversations with your client. The other roadblocks we're finding is mostly hardware-based as well. So in Brisbane, for instance, we've got a HTC Vive Pro with a very powerful desktop machine. We bring the client in and they get very excited about VR and what they can do with it, and then we have to explain, oh, well, actually, it's going to cost you about $4,000 to $5,000 as your minimum barrier for entry to be able to do that. And again, that's why things like the Oculus Quest, they're going to come with a whole bunch of their own constraints and considerations that we have to work through. But just the fact that we can just basically give over a headset and say, look, that's all you need is absolutely brilliant.
Yeah, I guess this is the kind of technology that once you actually get to try it on, it speaks for itself.
And that's the thing, like,
it's always challenging getting them. That's it.
Yeah, you always say to people, like, if you haven't experienced VR, like, you have to just come in and have a go. I cannot explain to you what that's going to feel like, and until you actually put the headset on and start to look at some of those examples, it's almost like the light bulb moment. You can see when the client, their eyes light up, and you're like, yeah, this person gets it now, and it's a brilliant moment.
Yeah, and it's like, I struggle with that myself. It's always tricky to kind of tell someone like, oh, put this headset on. It's gonna be a great experience for you, because you also get the eventual person that had a really bad experience on VR at first, and now they're like extremely reluctant to try it again, and it's kind of, you even have to try a little bit harder.
Yeah, and it's especially if they've had to go of a headset where, like, the rotation is taken away from them. We tend to find that things like the Vive in the room space, people are always perfectly fine, but it's like when they had to go in a shopping center of a VR roller coaster experience or something. But having said that, we have seen some funny things when clients put on headsets and kind of get confused about what's real and what's virtual. People try and lie down on virtual beds. People get so excited that they forget to look at the Guardian system and they run straight into the wall adjacent to our VR space. Like, it's pretty crazy.
Yeah, it's actually, I found it best to see how people react when they're experiencing for the first time. I remember on our Sydney studio, we had one client that started swearing and telling everyone else around, like, God, like, this is very good. You need to try this. and it was like a completely groundbreaking and mind-blowing experience.
Oh, well, can you remember your first time, like, putting on a proper, like, VR headset? It just blows your mind, doesn't it?
Yes, definitely. Well, thank you very much, Michael, for the presentation. There is another question coming on from Gio, and I think that's a very good one that I know for a fact Alex is going to be able to talk to as well. How do kids react to VR? So I'll leave that one to the very end of the session.
Yeah,
thank
sure.
you very much, Michael.
That's all right. Thanks, everyone.
Now, moving forward, we have Jahn from the Netherlands. So Jahn is Design Technology Director at Meccano Architects and Vice President of Product at Arkeo. And I will let him explain what Arkeo is and what Arkeo does. So thank you very much for joining us, Jahn. And now this presentation is going to be a bit of a test. What's going to happen is that I'm going to be joining. So I have my iPad next to me here, and Jahn has his headset ready to go. What's going to happen is Johan's going to be presenting inside the Arkeo platform, and I'm going to be joining him and following him around on the iPad, so you guys can see the presentation from within the platform. So thank you very much, Jahn. Over to you.
Yes, so let me quickly start my sharing of the screen. And so I'd like to talk a bit about Arkeo first, and let's see if we all get this stuff to work. Like a little side note here, we're going to be a bit experimental with this feature. Can everyone see the feed that we're currently streaming?
Yes, we can see.
You can see it? Okay.
Yeah, so on the right side, for the people in the audience, at the right side, it's my the screen of my iPad, and on the left side, you can see what Jahn sees inside the headset.
Yeah, so I'm using the VR version of Arkeo here. Arkeo is a collaborative spatial design application. And we're going to talk a bit briefly about this using a couple of these slides. So I'm just going to move to the first slide to tell a bit about where we're going. The process of architecture, I think we're all familiar with. How we create ideas is often still based on sketches or even foam models. But nowadays we mostly work in 3D applications, and we do that on a 2D device. So we're still using a PC to look at a 3D model. We're even presenting our designs of our 3D model on a piece of paper to our clients. And with VR, let's move to the other side. We're now able to, and respond me. So with VR, we're now able to step inside these models, and we can perceive them from the human scale. We can actually see what the design will be like, and we can respond to that directly. Now, when we want to do a change, we have to go back to our flat screen and to do the change there, and we have to push that information back into VR applications. So it's not really a seamless process yet. And going to the next slides to talk a bit about that. So what we want to do with Arkeo is we want to use these immersive technologies like AR and VR to offer a new experience where we can reimagine how architectural design can be like when you're not bound to these 2D devices, when you're able to interact with your space using your hands. So physically picking up objects, sliding objects, like you would be using a physical model. Now, going to the other one slide. So we want to enable people to load in any of their original 2D creations, be it like a Revit model or a Rhino model, and make some proposals on top of that model using a variety of different tools. So enable, for example, to make a new design proposal on this side of the building, and maybe adding a small object. Everyone can still see the screen feed. We're not presenting here for no one to see.
No, we can see everything very well.
Great. So we basically want to be like a virtual tracing paper, like a 3D tracing paper where you load in any of your original models and draw on top of that and load that result back into the original application. And the best thing of all of this is that we want to do this fully collaborative. So we're like now in this session together, and we can invite up to 10 people to be in that space and to model on different skills. For example, the God skill, where I can look down on the model, or on the human skill, where I'm able to use tools on a distance and having like a design superpowers to work on it. Yes. And we also want to enable this on all sorts of mobile devices, like Andres is now using his iPad. We also support mobile devices like the Oculus Quest that other speakers briefly talked about. And that's like a real, like that Quest is a real eye-opener in terms of like usability and ease of use, because it doesn't longer need a PC or wires or complicated setups. It's a $400 device that has all the benefits, 6 degrees of freedom editing, and it supports RTO as well. Like an interesting thing to note is we're currently in a beta, and so RTO is available for testing if people are interested. And we're also still developing it heavily, so we're also planning to release the AR clients for the new AR headsets that are coming up, like the HoloLens 2. Now, creating a tool like RTO was not an easy. We had to build our own modeling kernel in order to support real-time modeling applications at the frame rates needed for these VR devices, and especially being able to do that on a mobile device like a cell phone, we need to optimize it a lot. We made our own volumetric database, so and it's all parametric. The information you're making, it's actually extendable, and it has a lot of overlaps with tools like Revit. And I think the best to just show you is just show it live and go away from here a bit and look at the total of this scene. So we're currently like in a part of Melbourne, and we think we're at the riverbank right now, and we removed a part of the strip to make some design creations on here. So I'm going to in on this spot, and so you see I'm using my hands to scale around and move anywhere. And Andres, I think, can follow me. Let's see if he can find me. Hi there.
Yeah, so, yeah, I'm trying my best. I'm not very clumsy with this, but I'm trying my best to follow you around.
It's a lot more easy in VR because you can just grab everything, and it's like a bit more like close to the human mind. I'm going to switch to like a split tool, and I'm going to make a shape here which automatically calculates the floor slabs. So let's just make another shape like that here. And let's put that like a boolean inside of there. Now, the nice thing of RTO, if you mentioned it, is like all of these objects are parametric, so I can keep making changes to it without having like the data is never really lost. So I can even jump in the one-to-one scale and look at that building. Like this is the station building, and make some edits on the spot there. I can even move that entire building if I want. Move it somewhere else, but let's just keep it somewhere there. And let's show you some of the other modeling capabilities we have so far. So I'm going to make another shape over here, and carving into the shape. Stretching it to be connected to that face. And we're not only bound to making boxes, we're actually able to go inside and stretch these features like you saw me doing in the small example and make more complex shapes. So we start off with our primitive shape, and we can later edit that to the size that we need. Let's make another shape over here, and another one over here. And let's make a small tower or more of a high-rise building over here. And it up there. So what do you think of the scene I'm creating so far, Andres?
Well, I don't know. I don't know if it complies with council regulations.
Like, you're familiar with this area, right?
Yeah, a little bit.
So let me just
So
show you something.
I can start doing things here as well, right? With the iPad. I'm gonna try and do something.
What is an important road on here? Like,
I'm going way past the height limit, but that's fine.
We can make it that high. Let's just do that. And I'm going to show like another, like one of the smart objects we have in here. So I'm going to use a hollow shape, and the hollow shape has the advantage of being like a parametric hollowed out shape, so I can easily make window openings or like interior spaces, interior spaces. And let me just, something is moving.
Yeah, that's me.
So I'm going to just make a core here. So this will be a stair core, and maybe you want to put some elevators in there later. And let's put a wall here, and maybe add another wall for bathroom. Maybe make it 2 bedrooms. And let's add a tiny door. So it's really close to that at that time in university when we were making physical models. You're just using your hands to create these things. And over that we have, like you see, like when I'm creating the shapes, and actually guides show up and things automatically lock into place with dimensions that we think make sense. And if you want to work or extend on them, you can just like jump in there and work at any scale and adjust them. So I'm just going to finish off the windows with that here. And I'm going to jump inside that building. And then now in human scale on that apartment we just created. I can actually invite you here with me, so let's just do that. So you're now behind me, I guess.
Yep.
So let's just, I'm making myself a bit bigger, and I'm going to add some furniture in here. Add some chairs for scaling. And let's add a little table. And these objects themselves, they are interactable. Like you can actually pick them up and rotate them and position them anywhere you like. And let's just add a little bed here to give some release for the space. Now, there's a lot of things we needed to think differently, and then building an app like this. I'm going to leave the bed there, like it's okay. We needed to make a special interface that makes it very easy to work with without polluting your screen. Like normally in a fixed screen, you have UI that can be fixed in place, but in VR you want to have things simple, and so we innovated a lot with that. And we also added a number of features that are very useful for architecture. So right now we're currently looking at the file in like a white mode, but I'm able to add program data to these objects that I made to show the smartness and the sizes of the buildings we just created. So I'm just going to zoom a bit out, and I'm going to just add height to all of these things. That's a very large floor you made there. Okay. So right now we see all the totals change in the overview of our model, and all this data is able to update in real time. So we're able to just make some adjustments to these volumes. Let's just finish up the painting. Almost there. and that one, that one, that one, that one. Add some commercial area on the bottom floors. And then we are right here. Briefly peek this, yeah, everything is still visible. So when we want to make adjustments to that design, we can just go in there and we'll just stretch that the commercial floor up to 6 meters, for example. Let's just stretch that one up. And all of the connected geometry will move with it. So let's just move back that very large floor you made there. So a little bit more realistic. And finish off that floor. So now we have all the totals in this scene and we're able to edit and adjust those accordingly. I briefly mentioned, actually I didn't discuss that at all, but this model is loaded from Revit. So what I'm seeing here, this Melbourne model came from Revit, and I'm able to load all types of models in ArcGeo. So I'm doing that with one model right now. I'm going to create a new model, and this one is a tower design we want to place in this design. So I'm going to place it as an object. Now this will take a bit of time to load on the iPad because it's a rather big model. But once it's in my session, I'm actually able to pick it up and work with it like any other shape in ArcGeo. So this tower can be positioned where I want to align it. And since it's a 3D object, I'm also able to do more with this. Like I'm able to actually go inside and check out the design from one-to-one scale. So this is that tower, that view from that tower in there. I can actually get you here with me again. Let's see, there's something there. You're in a column, I see. So like we can, since we're drawing on top of a model, we're able to like make quick proposals like this, where I'm making, maybe filling up that space with a cube. And since we're in VR, we're able to directly see that spatial quality of doing that change. And we can even add some people to the space to make it a bit more understandable in user skill. And this would be able to load back to the other applications that we'll show soon. Now, let's show some of the other features. I'm going out of this building again. And I'm going to add some volume right here. And you see when things are created, it automatically snaps and hosts these objects on top of each other. So I'm able to work with these volumes by picking them up and able to make arrays, for example, arrays going up, simple arrays. But I'm also able to give them a slight offset. So let's just do that here. And make the array, let's do that again. So we can the shape, give them a slight offset, and then make the array going up like that. So I can make a rotational array. We can even do that from that human scale if you want, if you prefer to work in that design on the human scale. You can just place a tree. You want to place a tree on the building, or place it there. And pick up that tree, make a copy of it, and just maybe array it all the way across the road like that. So let's just finalize this design for the strip. I'm going to add another design here, maybe another one over here. And I'm going to jump in here and show like one thing that architects, we always like to do that as well. We like to work with options, like explore different design ideas together. And we built something specifically for that. It's called the model carousel. We're able to, at any point in our model, make a duplicate of our scene. So I just made a duplicate where I can fiddle around and change some things. So maybe I want to move that part of the tower all the way here. And maybe I want to move that building a bit there. So then I'm able to switch back and forth between those different options with everyone in my scene, and people could be standing in different viewing points, and you can make good decisions based on the human most optimal position. Like once we're happy with the results, we can export our results to applications like Revit. So I'm just which I'm going to export now. Let me briefly make my transition to Revit here. You're able to see my Revit screen? I hope.
Yep. Yeah, we can see.
Great. So I'm going to use the import feature here, and like for the exercise, I just I'll pick the model I just created here, but I have one already loaded in the background, so we can speed up that process a bit. So I convert my geometry that I made in Archeo to a mass because I want to work with masses in Revit. And every object that was positioned and placed in Archeo will actually be transitioned to a native Revit component. So, for example, that tree that we have, or like the imported building that we placed in that scene, it will be converted to a family, and that family can be updated to any other 3D family that you have in the project. So I think I did make a little mistake here by thinking I can just go to the other project. Now my Revit is loading. So talking a bit more about this, the masses itself, like once you're working in Archeo, you're working with the stacked shapes, so we're able to work with individual floors. Once you convert it to masses, it will join all this geometry together again, so you're able to work with the mass feature in Revit better. Also the sketches, little notes that people put on the model, it will be converted to Revit objects, and hopefully now we'll start kicking in. All the program information will also be contained, so we're able to really have like whatever was decided in that meeting or whatever was added, we'll be able to work with that information inside Autodesk Revit.
No, it's a very powerful tool. I mean, the demo is obviously showing it. I do want to add for everyone. Sorry about that. I do want to add that on your screens, you might have seen a very laggy version of the demo depending on your internet connection. So it's worth noting that what we were doing now is, so Jahn and I are connected via a Zoom call on our devices. So we were essentially streaming the Zoom call into here. So the lag is obviously a result of having multiple internet connections kind of going on at once. But on my iPad, what I'm experiencing is actually completely real time. Like I don't see any lag whatsoever on my end from what Jahn is doing.
Yes, well, also in VR, like if I would have the frame rates that I'm seeing now on PC, I would get like it's a much smoother experience. I think because we're going from Melbourne via Zoom to me, then I'm going again streaming back to Melbourne. I think we're really pushing it a bit here, but the experience itself is a lot smoother.
Yeah, exactly. We do have a question now, so I think it might be time to jump onto it. Bren is asking, can IKEA be used beyond the feasibility and massing stages? Assuming the question is being asked towards the architectural stages of a project.
Can you repeat that question a bit, because I didn't hear it that good?
Yeah, sorry. So the question is, can Archeo be used beyond the feasibility and massing stages? So I guess rephrasing the question, how has the tool been used apart from, the initial conceptual design stages of a project? Do you have any case studies?
That's a good question. Like the example I did inside that that building I loaded, that shows how Archeo could be used in later stages of the design. Like I often still notice that when it's like design stages need to be a bit more extreme and considerate. People often don't prefer to work with tools like Revit, but they go back to tools like Rhino or even SketchUp to do these studies of like different proposals there. And that's where we want to position Archeo, because you're able to work with native Revit geometry that you're going to create in the end. So you're working on top of that Revit or Rhino model. You're quickly drafting out some ideas, and you can push that information back to the original software. So you won't have those like workflow breakings that you would have with traditional flat screen design tools.
Yeah, right. So I mean, obviously the connection to software such as Revit is quite useful and makes it usable beyond the initial stages of projects. Thank you very much, John. This is a really interesting tool, and the better I understand is out. So I will encourage everyone who wants to give the tool a go to reach out to Jahn and arrange a little demo. It's a fascinating tool, and as you can see from the presentation, you can do quite a lot within it. Thank you very much, Jahn. I think, just conscious of time, I think we might go on to the next presentation. I will be, as I said before, directing questions towards the speakers at the very end. Yeah, cool. I saw the screen, did something funny for a bit. Thank you very much, Jahn. Thank you for presenting. Now, I will encourage everyone, please keep asking questions. It's always good to know, particularly from people that have been trying to use or have been advocating for the use of VR within their working environments. It would be also good to hear from you. You know, what are your experiences? Kind of engage with the speakers in conversation in that way as well. So without any further ado, I would like to welcome Alex Colomb, which is joining from a pretty cool virtual location, apparently somewhere in New York. So it's very early over there. And while you might be having a little bit of coffee, we're having a little bit of wine, but we really appreciate you joining us here. Now, I think I'm going to struggle introducing you because you do a little bit of everything, to be honest. You're a little bit of a Renaissance person when it comes to extended reality. So Alex is the creative director of Agile Lens, which is an extended reality creative business. I think you will do a much better introduction than me on what you do. He just does a lot of very fascinating work. I saw him for the first time present in Singapore, and it's just mind-blowing because he goes all the way from designing exercises to just playing around and really pushing what VR can do and showing people that there are other uses to VR that you wouldn't even have expected. So I'll hand over to Alex. Thank you very much for joining.
Thank you so much. What a lovely introduction. Yeah, I'd say probably the easiest way to describe me is just XR evangelist. I've been very excited about this technology for a long time, and my studio based in New York City focuses on creating custom XR experiences, but also there's a whole consulting angle where we, just recommend and teach about everything out there, including a lot of the turnkey solutions out there, like some of the other presentations today. So there's certainly situations where we'd say, hello, potential client, just go check out Archeo. It'll solve everything you need. But inspired by some of the cool presentation formats we're seeing today, I'm going to try something new. I'm going to see if this works. I'm going to use OBS. And instead of sharing my screen, watch this. Let's see if this works. I'm going to go bam. And then I'm going to take my little window here, and I'm going to try to just scale myself down so I'm like a little part of the presentation. Whoa! Is that working? Can you guys see that?
Yep, we can see.
Yeah, blocking the Melbourne.
The screen seems to be flipped, I think.
Oh, okay. Interesting. Well,
okay. Yeah.
Oh wait, as in you can't read the text, like the text is flipped?
Yeah, the text is mirrored.
Okay, here we go. So I go settings, and then I say, I'm glad you pointed that out because I don't want everyone reading a backwards screen. I'm going to virtual cam, horizontal flip. Okay, how are we doing now? How's that?
Perfect, yeah, perfect. At first I thought it was a different language. I'm like, oh, but well, he's just showing off now.
Yeah, this is definitely showing off. Like, there's no reason to be doing it in this particular way. But it was like, can I do this? So yeah, so let's jump right in. We're going over to here, and you guys can see my mouse. Treat this like a laser pointer. So yeah, so going on this consulting angle, I'd say a lot of what AgileLens does is we sit down with architecture firms, real estate companies, now also quite a few folks involved with live events, virtual conferences. Just got finished working with the real-time conference, which was excellent. Check out some of those on-demand webinars sometime. But what we often sit down to discuss is, what kind of use case do you think VR would be best suited for your company? And we kind of think of it as this low risk, stable reward kind of method of thinking about it, and a high risk, higher reward where you can be more cutting edge, really be pushing the envelope with what these tools can do. But Steam VR is going to crash and you're going to have some issues. So it's what the tolerance level is for that. But the things I'd like to talk about today are kind of just 5 general categories for how XR, that is to say VR and AR, can be really useful in AEC. And in fact, all the presentations you've already seen so far today, I'd say also fit into these categories. So we'll be talking about how do you communicate as an architect or designer your design intent, the ways that this technology allows for pure creative expression. I think Archeo is just a great example of that, just being able to rapidly iterate through ideas, designing from the inside out, actually being inside of a space and then changing how the space feels and then having that be reflected in the construction documents, taking old problems that were traditionally solved in certain ways and now solving those problems in new ways, and then lastly, bringing people together. So yes, we've talked a little bit about multi-user experiences today, so I'll just briefly touch on how much of a force multiplier it is to have a lot of people in the same experience. So starting with communicating design intent. So this takes me back to when I first got started with VR in 2013 with the Oculus Rift DK1. I was working at a company called Fisher Dax Associates Theater Planning and Design that designs theaters all over the world. And a big part of that job involved making pretty simple, not even renders, just kind of screenshot exports from 3ds Max that were just meant to be very simple spatial communicators of different design options. So here you basically see the same view being communicated 4 different ways depending on how the seat is laid out. And I often found that when you sat down in a meeting to say like, okay, here's our 4 options, a lot of the discussion would be limited by this being an inherently 2D representation of 3D space. You'd have people saying like, oh man, the head in front of me looks way too close, or God, that stage looks really far away. When as soon as we were able to start using virtual reality, and again, this is very early days, 2013, 2014, representing that same information, but with someone inside a VR headset, you immediately get past this skepticism or misunderstanding of what the rendering is trying to convey, and instead you're in the space, and if you're cycling between these options, you feel the differences between those options. So the very first project we got to do this for was the Center for Chinese Opera in West Kowloon, China, with Bingtom Architects, and the response was quite wonderful, both from the architect and the client, because everyone just felt more like they were on the same page. So that really opened our eyes pretty early on to how this could be useful for us as designers, and then also getting really good feedback from clients and other collaborators when we could all look at VR together. And very briefly, I'd just like to say that that led pretty quickly into also thinking about the use cases of the architecture we're designing. So of course, in this case, designing theaters, we actually have performances in them. So Kenneth Branagh had a production Macbeth at the Park Avenue Armory in New York City, which I'm sure almost none of you may know. It is a huge space. It's the size of a New York City block. A lot of really crazy custom experiences happen in there. And there was a very compressed timeline to figure out how to get everything working. So really simple representations of the seating, the set design, the lighting, the actor blocking, just did worlds of helpfulness to help everyone feel like, okay, this is what it's actually going to look like. Great. So shorter timeline than architecture, but still relevant. And again, uses a lot of the same techniques. And that led pretty quickly into, what I would just call immersive visualization. So a lot of real estate work where it's like, hey, we're just trying to go from certain renders that are evoking a certain feeling, certain image of a space, and now it just let's make sure that people can actually interact with the space, navigate through it. This is being used a lot for pre-sales now in real estate, so that way they can set up something like this in a leasing office, and before the building is even constructed, you start to get people to sign leases, and they feel more comfortable with that versus a rendering, because they actually can have a sense of like, oh, it's a pretty big space or whatever, and see the views. And we always have things like you can play bocce ball and cornhole and things like that in these as well. So those are pretty straightforward. A cool project we got to do this for pretty early on was the Statue of Liberty Museum on Liberty Island with FX Collaborative, and we got to play with changing the time of day, and even going into the gift shop and playing with a Statue of Liberty model. Also, very easy to do a site model when you're building a custom experience in like Unity or Unreal Engine, because you can literally just take all of your assets and shrink it down to a smaller size. So that was pretty cool. And also because the building just recently opened, it was our first opportunity to get to compare a VR experience to the actual experience of being there. And so the Historic Society of Liberty Island, that's totally not their title, but the folks that we also showed this experience to, they were very happy being able to show this before the project opened to give people a nice preview of what the space was actually going to be like. So, communicating design intent can also be just good marketing once the design intent is finalized and things are under construction. So category 2, enhanced creative expression. So yes, the first thing I like to put forward here is that VR or AR does not need to be photorealistic to be immersive. All it needs to be is consistent. And the first excellent example I thought of with this was really the fact that we used the word immersion, which to me evoked something like being underwater. And I think that's a nice starting point to think about immersion, because when you're underwater, things don't look the same, things don't sound the same, things don't feel the same. If you could smell underwater, things would not smell the same. So it's a different experience for all of your senses, but we don't say it's unrealistic. It's just different within this other medium, I guess you could say. So with that in mind, an early VR experience that I really love showing people as a reference for this is by a friend of mine named Matt Colley, who runs a studio called Borrowed Light Studio. And this was a piece he did called The Night Cafe, where you are inside of a Vincent van Gogh painting. And it doesn't look photorealistic, but it sure does look and feel like you are inside a Van Gogh painting. There's no straight edges, there's no right angles. Everything feels like these long, languid brush strokes, and even the way the lighting works, the lamps and the starry night sky there, all feels consistent to this one world. And architects can do this too. You can design a space that is more gestural and sketchy and starts to feel like it's evoking the potential of something rather than saying, here's the photorealistic finished version. Something we got to play with this a little bit on the AR side was there's a historic in America, being like 1800s, a historic house a couple hours north of New York City, where there was an exhibit last summer called Architecture and Conversation with Nature. And we got to work with these artists and the Magic Leap headset and iPads to allow for this AR experience where you had these paintings and nature coming into the actual environment. So the iPads had this kind of stanchion setup where you could just kind of look through the webcam and see these different, things happening in the space. But the Magic Leap version actually allowed you to very freely move throughout the space and experience this really wonderful creative artwork in a new kind of way, spatially too. And then, touching briefly on some of the more theatrical narrative stuff my company's been involved with, this was an experience that we knew was going to premiere at a specific architectural site, you could say, a brewery, an actual location. If anyone knows what immersive theater is, we knew that was going to be happening with this ghost speed dating experience where you swipe left for the ghosts you don't like and you swipe right for the ghosts you do, pick your favorite at the end. And we were able to prototype this experience, which was going to be for AR in VR. And this is something I encourage anyone to do that's going to be dealing with something site specific, like a building going up on a construction site. And it sounds, again, like the other speakers today are also thinking about this stuff as well. And so you can use VR to prototype AR. So here you're seeing a very simple SketchUp model of the actual space that we knew the AR experience would be happening in, and then we could actually test it in VR, which was a great way to think about every aspect of how the AR experience would work for people on site. Number 3, designing from the inside out. So everyone knows about the legend of the napkin sketch, I guess you could say. It's this wonderful little thing that people are supposed to be able to do that then represents the potential of what a building could become. And I say that everyone should be treating VR programs like Tilt Brush and Gravity Sketch and, again, some of the sketching tools we saw today as their new sketchbooks, because these are opportunities to convey the same imaginative qualities of what a space could become that you get from a napkin sketch or something in a sketchbook, but now it's spatial. And so you can then be inside of a space and actually really feel how it is to come into the foyer, or a compression and release idea of moving down a hallway and then coming into a larger space without dealing with everything that comes along with the baggage of what exactly is that material, what's the wall thickness, and everything that comes on later with the project. So here you're seeing actually a tilt brush sketch brought into Unreal Engine and then used kind of as an underlay, trace paper, as was mentioned earlier, and then using that as a way to then mass out all sorts of ideas with just massing models, real furniture, lighting, and then eventually you can bring all of that back into Revit. This isn't anything proprietary. Like, you can just do this by using Tilt Brush, a $20 program, bringing it into Unreal Engine, which is free, and then exporting everything as an FBX, then converting the FBX to a DWG to bring it all back into Revit. So it's not like the easiest thing in the world, but it's certainly doable if you already have access to some of these programs. And so you're seeing there that basically, when I'm designing in VR, I treat it very gesturally. I'm not trying to be precise in there, but then you can bring all of that into a more precise tool like Revit, and then make the final construction ready version. So we saw a similar image to this earlier, VR trace paper. That's very useful. And then we've also done similar things with set design. So to keep going back to these theater examples, so you can sketch out something like a set design or anything that might be a changeable part of a piece of architecture once it's done. I also think about museums and exhibits, and you can test this stuff out in the space very quickly. Maybe not even you, but maybe even the potential users of the space. So we've done these kinds of studies with set designers while designing actual theaters. And then I've also had a lot of fun taking advantage of this particular feature of Tilt Brush, where it remembers every stroke in the order that you make it, so you can play back a sketch you've made for anyone inside a VR headset, and then they get to see kind of your whole design process play out really quickly. And this was an idea that came to me when I was thinking about what it would be like to design a space that could exist entirely within virtual reality, didn't have to worry about the built version, real budgets, real anything like that. So this started out as a sketch, and then I got to basically mass out the whole thing inside Unreal Engine, use the VR editor in there, and then have some fun creating that space. And so that's become more of a part of regular design workflow as well. This whole thing is being recorded, but you feel free to grab a screenshot of this if you want. These are just some of the tools out there. They're not very expensive, that allow for being very creative if you want to play with sketching, modeling, doing all sorts of things in VR. Number 4, new solutions to old problems. So these will be kind of some rapid fire case studies where we'll say, here's the thing that, that always needs to be solved with architecture projects. Here's a way VR, AR can solve that. So pretty simple thing, moving through spaces at scale. So yeah, it's very difficult to convey the actual sensation of moving from one space to another. Renders are snapshots of moments in an experience, and animation always has kind of a horror movie effect to it when you have like a dolly, kind of fly to a space. It doesn't really convey what it's like to walk. And so VR can be a really wonderful way to actually feel what that's like. So this isn't by me. This is a very talented VR artist named Matt Schaefer, and this is a great little sketch he did of a gallery space. And you'll notice that there's a few things going on here. There's sketching, there's massing, and there's also some thought going into the circulation and how people might move through the space. So you can imagine in a scenario like this, you could actually have the whole thing at scale and let people walk through the space on their own, do some user testing, and then compare that to how you want them to move through the space. And you could very rapidly iterate, make design adjustments until you're getting something closer to where these arrows are, for example. And then brown boxing. Who's ever done brown boxing? This is an incredibly time-consuming thing that I used to have to do when I worked at more traditional architecture firms, where you're trying to help clients, collaborators, etc., understand what it's actually like to be inside of a space. And so VR can be great for that, even in a very quick sketch format. Or this is by my friends over at Bevel Space. You can do these very quick mock-ups that maybe have a little more realism to them, but you're not worried about massing it or creating the entire building. In this case, you'll see this is a kind of a hospital space, and you can get this kind of ergonomic sense of moving through the space and grabbing different elements. And you can have a situation where, for example, maybe you have a doctor who's actually going to be working at a hospital that you are helping to design, and you can say, how would you like your OR to be laid out? And let them come into a little virtual reality mock-up like this, and they can say, well, yeah, I always want my sink to be within a 90-degree turning radius of where I'm standing here. And you can start to get some really valuable ultimate end-user input in this kind of fashion. Problem, specifying equipment in a very complex space. So we had the pleasure of working on the shed in Hudson Yards. Really crazy custom space. No one, even trained architects and designers, could really look at the orthographic drawings of this, the plans and the sections, and really understand what was going on in the space. So we created a very VR mock-up. This took like a day, grabbed a section box, brought this into Unity, and we said, this doesn't need to look good. We're never going to show this to the public. We'll never show this to the public. But we just need to understand what it's like to move through the space. And then here's the other thing. We have equipment that needs to be specified that is either going to need 4 feet of clearance or 7 feet of clearance. So you'll see all I did here was I took a 4-foot stick and a 7-foot stick, and that just kind of follows you around as you move through the space, as you also have that little scale representation person. And then we could actually just mark very quickly, on a little key plan, yes, we want equipment here. No, it won't fit this, it will fit there. So just really helps with spatial understanding. And then you see very briefly there's text popping up. So a lot of the geometry here is placeholders. So that's literally just querying what the name of the Revit object is and just telling you what the name is. So very quick mock-ups. Human scale UX for video mapping. If you ever work on a project with anything 2D, images or video mapping, you might think, well, VR is not going to be useful. It's 2D, but of course the 2D is experienced within something more spatial. So for example, we worked with Bravo Media on the Late Show with Stephen Colbert's renovation of the Ed Sullivan Theater, where there was a very short timeline to create this Church of Stephen Colbert effect. So creating a very simple VR mock-up that allowed you to basically steer the projectors around the grid and aim them allowed for a very fast process of just figuring out which projections would work best, what throw distance to give them, what focal length, and where to put them and how many, in a way where the traditional method for doing that would have much, much longer. Similarly, this was a very quick mock-up done for SOM of an atrium space where they just wanted to get a sense of what's it like to have some people moving around, and then they wanted to see some different options for this video mapping on the walls here. So these are just MP4s mapped onto the geometry. You could play with things like different color, different text, different gradients, different speeds, and it's so different just looking at the little tiny video of these things versus actually saying like, oh yeah, this is going to be a 50-foot wall, and here's what it actually looks like in that space. So you can really get into the nuance of the design, even little things like, yeah, how big should those arrows be? What color should it be? How quickly should they fade? These elements that can be very hard to not only understand yourself as a designer, but then again communicate to collaborators and clients. Now, here's the thing. We all, at some point, need to not just show people VR things, but also export 2D media. And so one of the ways that VR is great for that, you already have a fully textured, rendered, whatever stage the design is at project, then it's very simple, actually, to then output renders, animations, and more traditional 2D media to communicate the design at a variety of accessibility levels. So for example, this project for Yale, we actually were in VR laying out where we'd have the camera go for certain animations. You could call this like very simple virtual production. And that was incredibly useful to do that in VR. And this is essentially rendering in real time because it's all baked into Unreal Engine. Very easy. And then here's a project for Seattle Rep, where we needed to look at some different design options for a little wall on the side. And you're also seeing some photos there just to show you the difference between the Unreal Engine version and the real version. And obviously, the ideal way to look at the design options is actually this upper right image. Where is it? There, that one. Because that actually allowed you to see these three options and what it's like to lean near them or get further away. But a lot of people actually needed to have input in this process. Not all of them could see the VR experience. So we also were able to create, 360 videos of this that you could view on YouTube. That's what you're actually seeing down here is the 360 wraparound, where in YouTube you could just run with the mouse or with a Google Cardboard. And then we also had like web VR experiences that could all just be accessed from a browser. So this is all very easy to create once you've gone far enough to create the fully navigable VR experience. And then here's the thing. So this is a little bit tongue-in-cheek, but some architects sometimes would come to us and say, I'm very frustrated by this project. And at one point, we had an architect that we liked working with a lot, and he said, just as a little treat, we'll do this for them. We'll actually be able to turn on physics for their project so that if they want to, they can do something like this, where they can just light things on fire and break stuff and knock stuff around. Kind of a rage room cathartic release of, I'm just mad at everyone right now and just need to get this out of my system. And so this started out kind of just as a joke, just something to do for fun. But sometimes this stuff actually turns out to be pretty useful because Unreal Engine fairly recently has gotten an incredibly realistic destruction simulation system called Chaos in it. And so now, based on some of our silly experiments and adapting these to be more actually realistic, we're able to actually start working on really meaningful projects like life safety, fire safety, evacuation kinds of projects, where it's like, yeah, we actually need to be able to figure out how are people going to get out of this space if there's an emergency, if something's on fire. And you can even have things like, firefighters actually training inside spaces that are actually responding the way to a real physical environment. So sometimes even things that are just fun and playful can actually become meaningful. And then here we go. Here's the kind of the last big push here. This was a project that is currently under construction that we were lucky enough to spend the entire design process in VR with. So starting in 2015, you'll notice there's no materials, textures, anything like that here. We started out just with simple massing models, and this was just about spatial ideas. There's a blue scheme here and a green scheme, and we just wanted to be able to compare and contrast the two in a really simple way, put a few different elements on stage. Here's the blue scheme, here's the green scheme, and we're like, okay, step one, concept design, we like the green scheme better. Then we also wanted to be able to actively adjust the design from within the space, not just with sketching, but actually grabbing physical objects. So this is a little video from a company called The Void that has these wonderful VR arcades all over the world. But you can do this with a really simple mock-up using what's called a Vive tracker that you can attach to basically any object you have a 3D model of. So here, little Vive tracker attached to an Eames chair, and then that Eames chair becomes tracked inside virtual space. So what we could do is things where we like grab a real physical chair and then that automatically will snap to the closest chair to you in VR. And then as you move the real chair around to adjust for, comfort, sight lines, etc., that changes in the VR model and then can be piped back into Revit and actually affect the design. A few other things you're seeing here, playing with different options for the aisles, different things on stage, different options for seating, and actually experiencing how it feels to change between these options. You'll see up in the light grid, looking down to see like where can the lights go for the space in the catwalk. And then also, because this whole project stayed in VR, we can also kind of keep this memory of the project over time, going back and forth to the old SketchUp model, looking at the Revit version, and watching how the design progresses. Here's a cool little moment where we had a very old architect in here actually adjusting the railing design here to make it as comfortable as possible. So we had this set up so there were like code constraints and you couldn't put it in a way that wouldn't actually be allowed to be built, but it allowed for just saying like, okay, this railing feels right. You get to use an architect with a lot of design instinct to just say like, yeah, this is where the railing should be. And they don't need to sketch it. They can physically place it in a spatial context. And then again, that can make its way back over to the real construction documents. So here you see very quickly the SketchUp model, and then about midway through design development in the Revit model, and then later on where we started to think about colors more, but we weren't quite happy with where we were ending up with the colors and the lighting in Unity. So we actually ended up bringing this whole project over to Unreal Engine to really focus more on colors, lighting, photorealism. And what's wonderful is the VR editor, the out-of-the-box click VR editor inside Unreal Engine, allows for doing exactly what you're seeing here, where you can do something like just say, I'm just going to play with this color right now. And you can be standing in the space and just have a big old gradient ball there and saying like, okay, yeah, here's how it feels with warmer colors or cooler colors. And so what eventually happened here was, we started to narrow down a few different color options for the seats, the walls, and then could just toggle through them in VR and figure out which ones felt the best, which was really cool. Like I'd never been able to do that before and feel like we were coming up with the best option, because usually iteration time can't be that fast. And then going back to what I mentioned about Yale and the Seattle Rep project, anytime we wanted to just export these to people who aren't going to be able to look at it in VR, very simple to just do it from the Unreal Engine model. So here's where those colors were in 2018, and then here's where they ended up in 2019. And then, we also got to do things like start to populate the space and actually see, okay, let's now actually get a sense of what it's like to be in the space and move around it and jump around the different seats. Again, thinking about users of the actual space eventually, we could start to play with things like different set design and performances. There's some motion capture here, some volumetric capture. You could play with changing the capacity of the house. We actually had fun putting actors on stage and letting them see how it felt to perform to audiences of different sizes. And then here's a little quick drone cam of what it was like moving through the actual construction of the project. And here's something cool. Change orders are often a huge extra burden in the budgets of large architecture projects. I think the average is somewhere between 10 and 15% of a construction budget goes to change orders. This project is looking, I don't want to quote a number that's going to be wrong, but let's say significantly lower percentage of the budget going to change orders. And I think we can attribute a lot of that to how much of the project has been spent in VR. So there aren't as many surprises, and that's pretty great. So very quickly, this was just kind of a fun thing where I grabbed a couple images off the Instagram of, this is the Brockman Hall for Opera now, and I just literally dropped these Instagram images on top of our rendering. So it's kind of cool to see how close the final construction as we get there is to what we were able to render out of VR. And then I just have to show this image. These are actual moments we've had in our projects in the past, where it just goes to show how important it is to communicate design clearly. You have these issues where things are not interpreted as they should be, and this is always what I imagine is happening when that happens. So the more people you can get to experience it in VR, especially once you get to the construction side, the fewer weird mistakes you're going to have. Last step, bringing people together. Multi-user is great. This is not quite the out-of-the-box multi-user template out of Unreal Engine, but this was the Kennedy Center where we were looking at all these different options for the ceiling. Again, here's an example where there's not a lot of lighting or texturing or anything like that going on. It was about evaluating these different ceiling options. So this is a very simple way to get multiple people into an experience, and they can be in 2D, VR, some people in 2D, some people in VR, and everyone gets like a nice little laser pointer, and you can talk to each other, and have in this case, the major modification I made was the ability to have a host that guides you around the entire experience. So everyone can look wherever they want, but there's one person who says, hey, we're going over here now, and here's what we're looking at, and cycling through design options. So that's a very simple, out-of-the-box tool that if you have any familiarity with the Unreal Engine, check it out. If you don't, feel free to drop me a message, and I'm happy to help get you started there. And I also had the wonderful benefit of designing a piece of architecture for the Venice Film Festival last year that was going to be experienced entirely within virtual reality. But the same way that I'd be designing a real piece of architecture, I was able to use these tools like the Unreal Engine VR editor to mock up, again, what it would actually feel like to be standing in that space. Because your body doesn't really care whether you're in a virtual space or a real space. It's still going to react to a lot of these elements in the same sort of way. So to wrap up, we've talked about communicating design intent, to just help people understand, here's the design, try to understand it. Being more creative when you're working your design on your own. We talked about actually designing from the inside out. I didn't show a few other examples of things where we would do things like grab a ceiling or a wall from within VR and literally just push it until it's just so, like just exactly where it wants to be. We talked about finding all sorts of different ways that VR and AR and XR can help to solve old problems in new ways. And then multi-user, just a couple brief examples of what it's like to get a lot of people into the same experience and be able to have really meaningful discussions about the design when you can have, say, for example, a guide in there to help everyone look at the right things, and then also just feel like you're not alone in VR. Then it's not too isolating. And then if you enjoyed this very quick flyby talk, I'd also recommend there's kind of a sequel to this talk that you can check out on my YouTube channel at iBrews, where then I go deeper into like, okay, but if you're going to build a VR experience or AR, how do you make it really meaningful, and how do you target it to your audience and make it really do what you want to? So feel free to check that out. And really, I would just say my whole goal as an XR evangelist is I'm trying to move beyond where I see a lot of VR right now, where you're kind of going back and forth a lot between a computer, 2D modeling and looking at something in VR, more of a design review workflow, and then eventually getting a building out of it. And I'm trying to move more towards just, you can look at things and make meaningful design decisions in VR and have that actually be what ends up being the final result. That's where we're headed. Thank you very much. I know I spoke very fast, and we're a little bit over time, but maybe time for one question or something.
Thanks, Alex. I think, well, I mean, I knew this was going to happen. I knew by the end of the session I was going to be like, oh gosh, so many questions, so many things, which is a good thing, because there's, very few times you get exposed to so many ways of using VR. And it's actually amazing to see all the work that you've done and how it actually impacts the people that use it. I think I do want to ask you something before we get started with the overall forum. And before I do, I apologize for everyone. We are running a bit over time, but I think, it's you don't always get to be on one-on-one virtually with presenters such as them, which are extremely experienced on the area. So I do encourage you all to stay to ask your questions, because it's worth taking advantage of the fact that they're here. So Alex, a question for you. Out of all the things that you've done, what has been the most surprising or the craziest experience that you've had with a client using VR?
Well, going back to talking earlier about the way that people respond sometimes unexpectedly to VR, AR, I'll bring up two quick examples. One was the Statue of Liberty Museum project with FX Collaborative, where I was so excited to show them that Unreal Engine project, and they put on the VR headset, and I was ready for them to like take it off and say, "This is amazing, thank you so much." And instead, the architect took off the headset and just kind of sighed, and he was like, and I was like, "Oh, what's wrong?" And he's like, "I really wish we had looked at this a lot earlier, because for the first time he was seeing parts of the project where he's like, oh, is that really how that wall detail looks? Is that really how that joint condition happens? Because then he wanted to make changes. And so that was when I really started to realize how important it is to start using these tools early on in the design process, so you don't get to that point where it might actually be too late to make design decisions. And then very briefly too, we had a group of young architects who were very excited about the potential of VR, and one of them put on a headset and immediately said, oh my God, wow, can I run forward? And she didn't wait for us to say, no, don't do that, and slammed right into our window. And we're 6 stories up, and like, thank goodness the window did not break. But yeah, it's crazy sometimes seeing how quickly people respond to like, this is reality. This is the new, everything that I see is real. So yeah, you get people trying to lean on tables or sit in chairs that aren't there. And by the way, it makes a huge difference if you can place a physical chair, even if you're not using the Vive tracker, if you can place a physical chair in the real world that corresponds to a virtual reality chair, just so people have that clear reference point of like sitting down and standing up, that really, I find, helps people just a pro tip there.
Gosh, yes, be very careful of the physical environment when you're using VR. Well, thank you so much for your presentation. I think now I want to open for general questions for the whole audience, and there's quite a few coming in. So I think the best way to do this is if all the presenters and hosts could turn their cameras on, just to bring a little bit of a human element to the presentation. I think the best way to do it is if you guys have a look at the bottom of your screen, you'll have a raise hand button, which is doing something like this. So if you guys have a question, you can either drop it on the chat and we'll direct it to whomever you're asking it to, or general to the audience. Or you can click the raise your hand button and we will hand over the microphone to you to ask a question directly to the presenters. So I think, and yes, Michael's without camera is all good. I think to get started, there's a few here already. Also worth mentioning, Gwyllim, our first presenter, unfortunately had to leave the session earlier, but in his place we have Nick Vandenberg, who is the CEO of Fologram, so he'll be able to answer all Fologram related questions as well. Okay, so I think starting off with one question and open up for everyone, but I think maybe in particular for Michael and yourself, Alex, when you're dealing with clients, there's a whole number of things that can go wrong when you hand over the controllers. From people getting into the walls of buildings to as you very well said, going physically clashing against something. Are there any tips that you have for people as to how to navigate or manage a VR session with someone? Or do you guys have a bit of a ritual, to kind of ease people into the virtual environment?
Yeah, look, I can jump in. So yeah, look, definitely we do. When the Vive first came out, there used to be, I can't even remember what it's called, but there was like an app that let you just drop into a few like photogrammetry captured environments just to explore. And I remember one of them was a bedroom, and it had like a very small flight of steps at one end of it. So what I would do was get people in the bedroom. Yeah, that's it. Thanks, Alex. Destinations. Yeah, so we get people in the bedroom to understand kind of the room scale, and then I would ask them to teleport to the top of the steps and then turn around and I would ask them if they would feel comfortable stepping forward into the void. And we would typically use that as a bit of a way to gauge whether or not somebody was feeling entirely comfortable or willing to try things. Since then, we tend to do the same thing, but we use our Brisbane Airport model, where we'll get somebody to stand on the sky bridge right at the very edge, and again, we'll say, hey, why don't you take a few steps forward? And that's kind of our litmus test, I guess.
Yeah. I'd say always make sure to show someone how the controllers work before you put on the headset. I've seen a lot of people, they get all the headsets situated, and then they're trying to like fumble with someone's fingers to be like, this button is this, and this button is this. Also, ideally, if you ever have control over what the controllers are going to do, make it as simple as possible. You know, especially for someone new to VR, give them like one thing to do, make all the buttons do that one thing, or just like the trigger. But also, it's really nice that more is happening with hand tracking now, because we're finally getting to that point where if you have, you know, an Oculus Quest or something like that, you can just avoid the controllers altogether and say, like, every time you want to do a thing, just, you know, snap your fingers together.
Yeah, there's nothing like a surprise touch in somebody's first VR experience. Tap on the shoulder.
Yeah, like it's like very common to have when like people first try it, that they instantly put on the headset and they don't even have time to like look at the controllers and what they're actually like. Most people are still new to 6 Degrees of Freedom VR, and I think that's something we can also not forget. Like a lot of people, they have like a pretty bad first experience with VR because they watch like a Google Cardboard or something. So the first thing you're often having to do is to explain that this is a different type of VR where you're having spatial interaction and controllers and buttons to press. So it's good to tell people about those buttons before they get in there.
Yeah, well, sorry, I ran out of battery on my earphones, and now I'm using the headset. Can you guys hear me well? I'm just making sure.
Yep.
Perfect. It seems like I'm joining the virtual environment now a little bit better. Another question for everyone, and I think a very relevant one for anyone studying. Are any of you guys using open source game engines for the commercial products? And if so, what do you guys think have been the greatest advantages and disadvantages of using those? And which ones are they?
I don't know if Alex wants to say anything because he's the game engine expert.
My answer is pretty simple. We're using Unity and Unreal Engine. They're not really open source. Unity, there's a way to get the source code, and it's very expensive. Unreal Engine, you can edit the source code quite a bit. But then, yeah, it also just affects the way things get priced if you're creating something very commercial. But there's tons and tons of resources for anyone that is like, I'm a little intimidated to get started with this stuff. Unity just made their entire premium, like paid subscription to tutorials free. And then Unreal Engine also has Unreal Online Learning. I have a couple courses on there. So they're both great. Plus, you know, the millions of YouTubers posting stuff as well.
Like a thing I like to add there, like we are like Arceus based, or these we build it on top of Unity, but we could have also built it on other platforms. But what really also helps a lot with these game engines is the information to be found online and the community around it. And these existing game engines like Unreal and Unity, they have really large communities, lots of knowledge, lots of open sourced sub packages of like things that you can use as well. So if you go for a complete open source game engine, that's not one of the two big players, you often have to be a bit more comfortable with tinkering on the code itself and like really reinvent some of the wheels, because the big game engines often have a community that already built that for you. There's new questions. Are you still with us, Andres?
Oh no, we lost our moderator.
We lost our moderator. Now we need to moderate ourselves.
Like he's dropped out. I'm gonna ask actually one of my questions regarding the contract terms in XR experiences. I mean, people can have different in different takings from each XR experience, how they can put that into contract and like saying, okay, this is the thing I want to get at the end. If that makes sense.
I can jump in from our perspective at Oricon is that we're quite careful. Typically we'd hand over the executable file at the end as a project artifact, but that's not really essentially what we'd prefer is that we use that as a tool to help us internally inform design decisions. So rather than selling some sort of VR experience, we're selling an outcome of which VR is a tool that goes into producing that outcome.
How about AR experiences? Does it also go out as an exe file, or?
So personally at Oricon, we haven't really jumped into a great deal of AR, so I'm probably not best placed to answer that.
Okay. Not sure if Andres is back, or it seems like
you're doing great, Haas. You're the substitute moderator.
We have another question regarding VR headsets. People tend to get like really dizzy after a few minutes of usage. Is there? I mean, it's a natural thing, but is there anything you guys, as a experienced designer, can do to make it a little bit better for them?
The most important thing I can add there is really make sure that these frame rates are high enough, because that's like still like an issue with like even some of the games out there on Steam, like when frame rates are below a certain threshold, the experience itself will be very uncomfortable for everyone. And some people have more C or like VR C legs than others, so they can endure lower frame rates or like awkward locomotion things that's like a game decided. But like with architecture, we're often tempted to just throw the entire Revit model in there and then expect this 20 million polygon file to just render at 90 frames per second, and that's like you need a pretty powerful machine in order to.
Yeah, that's the answer, right? Just get a bigger graphics card.
Just
brute force it.
more equipment, or lower your let's say lower your standards and what you wanna or like think about what you wanna achieve, what you wanna talk about or like discuss, and focus on getting that information in and not all of the information. And that requires a bit of planning, but that's still good to do with VR, because that time is valuable as well. You need to get that equipment set up. You need to have these people all like there, and like some preparation there helps a lot to make that a more smooth and pleasurable experience for everyone in VR.
And accessibility options is important as well. I think Tilt Brush is a really good example of a program that has like the simple out-of-the-box version that just works and very intuitive for almost anyone to get started with. But then you can turn on all these advanced options that allow you to go much more granular into the experience. So for example, locomotion, how you move in VR, it's great anytime an experience gives different options with that, because the locomotion option that is least likely to make people sick is teleportation, but it's also not a great representation of actually moving through a space. So smooth movement is more realistic, but that can also make people sick. So then there's also experimental methods like you swing your arms and that's what moves you. So having those kinds of options available, I think really help make an experience feel the most comfortable and the most useful to the people who are actually going to be using it.
Okay. There's a question from, I think, Travis Rothblum regarding, he wants Alex's experience and thoughts about Magic Leap.
Man, how do I be diplomatic? Hi, Travis, with me. I mean, I've had a wonderful run of using Magic Leap. I've still, oh God, I'm going to change where my webcam is, but I still got mine. It's right here. and I'm still using it quite a bit, but I am nervous about the fact that, pretty much their whole dev team was fired, because the thing I liked most about working on Magic Leap and developing it was they were an incredibly supportive developer side. Like anytime I had any question about, like, I'm doing such and such in Unity or Unreal, or like, what do you think best practices are for this particular hand gesture, there was always someone there who was very quick to help out and answer. And they've lost that right now. So even though I know they're hard at work making Magic Leap 2, which I hope is going to be amazing, I am definitely hesitant right now to start any new projects in Magic Leap that aren't going to be using tried and true techniques that I've already used before.
I think the AR headsets are really developing very slow. I mean, it took a long time since HoloLens and HoloLens 2 came out. Not sure what the technical difficulties are there, but it seems like it's developing really slow.
Like an interesting thing to add there is like the Oculus Quest is also doing some pretty amazing stuff regarding like innovations they're able to push in software. So it's definitely a headset to pay attention to, because they Facebook announced that they have ambitions to go down the AR road. And like if you use the latest version or the latest update of the Oculus Quest, it already has a very good working AR pass-through. Very like solid hand tracking, so they're definitely trying to make that device more and more into an AR device, and that will be like 1/10 of the price of HoloLens. So definitely interesting to watch that.
On that note, really quick, when I consult with companies to help them figure out VR solutions, a big part of that discussion used to be like which VR headset is right for you, and in certain cases I'd recommend Vive or Windows Mixed Reality headsets, or higher end, more custom versions. In almost every case these days, I'm recommending the Quest, because, as Jahn was saying, there's so much you can do right now, and Oculus is pushing out updates so fast. So there's hand tracking, there's the ability for it to be totally wireless, or you plug it in with a USB, and then you're going to get all the graphics power of an RTX 2080 Ti or whatever is on that computer. And then, yeah, the AR capabilities now, like even now, you can turn on a pass-through mode that you can even experiment with in Unity or Unreal Engine. And it's just a really powerful $400 device. So highly recommend for sure.
Our favorite.
Okay, I think that's pretty much it. So don't have any more questions. One just came. With the number of startups that are developing such tools, typically subscription-based, and the limited amount of typical firm is willing to invest in these tools, how do you see your tools being adopted in the general industry?
I think what's important there is like most of the innovations from our industry, like our industry is a bit of a dinosaur. It's not moving very fast, but there are a lot of companies that are having a dedicated R&D department that are investigating these new technologies and how to use this. And those companies are very important for us, and I think any other developer, because they will pave the way to more developments to make the product more usable for the more general public and consumer. So those first power users are going to be very important for all the tools, all the different startups.
Nick from Fologram here. Sorry, my camera's not working at the moment, but also some thoughts around that. I think Michael outlined really well in his presentation where it's about focusing on value. So like, I mean, obviously Hologram, we work a lot with AR, and I guess when people, they like think what would be a fantastic AR solution for the construction industry, they're like, I want to walk on my 50-story building and look at any pipe, any HVAC, it all is perfectly aligned, and I can do my QA check and I can do everything. It's like, that's a great idea, but that's obviously something that, like, you know, multiple years into the future. It's more about like, what's the low-hanging fruit that works right now? So like designing solutions that can be used right now with what the technology is allowed. I mean, I think that's how basically the startups that are having success with their solutions is that where you're sort of finding, all right, in the case of that giant 50-story tower, it's like, all right, maybe is there some complex thing that needs to be done in the lobby, and a solution can work and do that, and that justifies the the cost and the investment. And that is just like anything else. You don't use the hammer on every single task within that building tower. So what can you use AR or VR for specific tasks that can work right now? I think that's well, definitely how we approach it anyway.
Like to add to that also, like the devices that are available, they're still limited. So the more devices you can support, the more useful it will become, and more easy it is for other people who are new to these technologies to also be introduced to this. So I think that's like something definitely interesting for general adoption. Like not everyone will have like a VR headset at home within like the next half year. But the people that will have, them being able to collaborate with people using a smartphone, that will help a lot in also getting them involved with the advantage of this technology.
Well, thanks everyone for the answers. We have, I think, Andrew's back. So
yes, back in the game. So
Yep.
can you hear me there?
Yep.
Perfect. So it turns out, I mean, of course, the audio driver on my laptop died, so I had to do a very quick change of laptops, but I'm back in the game. Yeah, well, I think it's very fair to finish the session on this note. Thank you, everyone, for joining. Thank you to all the speakers for their amazing presentations. It's been a very informative, as Sylvan said in the chat, a very, very valuable session. We covered a whole bunch of VR and AR and MR uses of the industry, from, how do you approach a client, or, what are the things that you need to consider, all the way to, wait, actually, you can burn and simulate things on VR and, branch out of the AEC industry as well in terms of what we do. I'd like to thank everyone, and yeah, please join us on, I don't know, I'm gonna clap myself here, but like you guys can add emojis to the chat or something to please thank all of our speakers, because they were all very, very great presentations. So thank you, everyone, and I will please encourage everyone to reach out to the speakers as well if you have any questions, and reach out to us if you want us to put you in touch with anyone as well. So thanks everyone, and enjoy the night. And for you, Alex of New York, enjoy your day.
Thanks for having us, guys, and thanks for everything. Bye, guys.
Thank you.
See you guys.
Bye-bye. Lots of thank you messages. Great. Still have some people in there.
Yeah, well, we're always happy to keep chatting if someone wants to.
Yeah, never shut up. There's actually a lot of things to discuss about XR. I think this is just like we could only scratch the surface in like a 2-hour session, but
yeah, of course. But
we've seen everything.
But it was a very good overview of everything that you can achieve, really.
Yeah.
Thank you, Andres. It was really good, and thank you, Johan and Michael.
Thank you very much.
Yeah, no worries. Thanks everyone, and yeah, thanks Andre for bringing me into this. It's been great.
Great to have you, Michael.
All right, I'm gonna jump off, but thanks everyone.
No worries. I think
Thank
I
you.
might jump off as well. I can't hear you, Johan.